that is CGS and MKS Units. Scientists have adopted the metric system to simplify their calculations and promote communication across national boundaries. However, there have been two ideas as to which metric units should be preferred in science. Scientists working in laboratories, dealing with small quantities and distances, prefer to measure distance in centimeters and mass in grams. Scientists and engineers working in larger contexts preferred larger units, meters for distance and kilograms for mass. Everyone agreed that units of other quantities such as force, pressure, work, power, and so on should be related in a simple way to the basic units. But which basic units should be used? The result was two clusterings of metric units in science and engineering. One cluster, based on the centimeter, the gram, and the second, is called the CGS system. The other, based on the meter, kilogram, and second, is called the MKS system. When we say, for example, that the dyne is a CGS unit of force, this determines its definition. It is the force which accelerates a mass of 1 gram at the rate of 1 centimeter per second per second. The MKS unit of force, the Newton, is the force which accelerates a mass of 1 kilogram at the rate of 1 meter per second per second. The ratio between a CGS unit and the corresponding MKS unit is usually a power of 10. A Newton accelerates a mass 1,000 times greater than a dyne does. And it does so at a rate 100 times greater, so there are 100,000 equals 105 dynes in a Newton. The CGS system was introduced formally by the British Association for the Advancement of Science in 1874. It found almost immediate favour with working scientists, and it was the system most commonly used in scientific work for many years. Meanwhile, the further development of the metric system was based on meter and kilogram standards created and distributed in 1889 by the International Bureau of Weights and Measures, the IPM. During the 20th century, metric units based on the meter and kilogram, the MKS units, were used more and more in commercial transactions, engineering, and other practical areas. By 1950, there was some discomfort among users of metric units, because the need to translate between CGS and MKS units went against the metric ideal of a universal measuring system. In other words, a choice needed to be made. In 1954, the 10th General Conference on Weights and Measures, CGPM, adopted the meter, kilogram, second, ampere, degree Kelvin, and candela as the basic units for all international weights and measures. And in 1960 the 11th General Conference adopted the name International System of Units, SI, for this collection of unit. The degree Kelvin became the Kelvin in 1967. In effect, these decisions gave the central core of the MKS system preference over the CGS system, although some of the CGS units remain in use for a variety of purposes. They are being replaced gradually by the SI units selected from the MKS system. Following is a table of CGS units with their SI equivalents. Note that in some cases there is more than one name for the same unit. The CGS electromagnetic and electrostatic units are not included in this table, except for those which have special names.